Hello, my name is Naji Husseini, and I am a teaching professor in the Department of Biomedical Engineering at both NC State and UNC at Chapel Hill. I'm also the Associate Director of the Undergraduate Studies. I'd like to tell you a little about the program and both what you will do as a student, as well as what opportunities you have at all of the locations. First of all, what is biomedical engineering? It's the application of engineering principles to problems in biology and life sciences, especially regarding human health. This is important to remember that we are focused on health. Once you graduate from the program, you will most likely be in biology or biological sciences. If you find yourself to be an engineer first with a passing interest in biology, biomedical engineering may not be the best of choices. It's possible to go from a mechanical engineering undergrad to biomedical engineering jobs. But it's difficult to go in the other direction, to say go from a biomedical engineering degree into something completely different, like say astronautical engineering. So consider your decisions very carefully, and if you find yourself to be a biologist and an engineer simultaneously, then this program might be a good choice for you. Again, if you're interested in something else like cars, like plasma engines, check into other departments because they might be a better choice for you. But that said, if you are interested, then our research areas in our department span 5 fields. I'd like to tell you a little about each one of these fields, as well as cite some examples of the research done within them. Our hope is that by the time you are a senior, you will have picked 1 or 2 of these areas to focus your electives on. And then once you go into the job market, you can present yourself as a specialist in one of these areas. The first area is rehabilitation engineering, or just rehab. This spans areas from gait and motion analysis to prosthetics to more fundamental issues like the material and mechanical properties of engineered and biological tissue. Some interesting areas of focus are walking, as I said, gait. With gait, you can imagine somebody that has had a stroke or some sort of other debilitating injury. As they walk, they have an asymmetry. The treadmill shown in the picture contains individual force sensors for each of the treads, and it can detect how well the weight is balanced, and then it can simulate stimuli. So somebody could be walking, a stimulus arises, and it causes them to adjust. And this can, by measuring the forces that are involved, this can help inform different types of treatment. With more fundamental properties, one might be interested in what kinds of treatments affect bone density. You might be looking at the effects of osteoporosis, or certain types of diet, or exercise. Does this increase the bone density? Does it alter the properties? Does it change the material composition? All of these things are of interest at the fundamental level. Finally, topics like prosthetics. Prosthetics can be both active prostheses, which have electrical power, or passive prostheses, which may just be there for structural support, or they may be present to harness the body's own energy, like a spring, to compress a spring and then to extend that spring to release some of the potential energy that builds up. Rehab is mechanical engineering as well as some materials engineering applied to the body. Regenerative medicine, or regen, is a little bit more of a squishier aspect of rehab. So with regen, you would be looking at implantable materials, sutures, wound healing, scaffolding materials, biomimetics, making things that simulate the body's properties, as well as medical textiles. The couple examples that I have shown, the top one is a breast tissue scaffold. With a scaffold, imagine having a building. A building is ready to accommodate people. But if there are people living in that building, you can't bring new people into that building. A scaffold is like an empty building. If you can fill that empty building with the host's own cells, not only does that building provide all the accommodations that those people need to live, but it provides them a structure to fill into. So by giving a breast tissue, that can provide structure for the cells to reform into that original design. The example with a heart is something similar, though with a natural polymer. The natural heart could be rejected by the host because it finds foreign cells present. By decellularizing the heart and then seeding it with the patient's own cells, you may be able to present a heart that will be accepted and not require as many immunosuppressant drugs. Finally, with more complicated things like textiles and sutures, these are all materials that are carefully designed to degrade in a certain time length, possibly have antibiotic properties to prevent infection. Examples also would include things like IUDs to prevent pregnancy by causing a low-grade immune response in the uterus or by releasing hormones over time. So these are all examples of regenerative medicine. This is chemical engineering and materials engineering applied to the body. Pharmacology is the liquid end of things. This is pharmaceutical science, drug therapies, drug release and delivery, as well as immunomodulatory biomaterials. Now, one thing that we do not necessarily do in our program is teach drug development. We're not developing new chemicals, new chemotherapy drugs. Instead, we work with those people and come up with new ways of delivering them and releasing them. So an example might be a typical drug to kill a tumor, which is a poison that could affect the entire body. The hope with chemotherapy is that the cancer will take it up preferentially and the cancer will die before the body is irrevocably damaged. With a proper delivery technique, you can imagine encapsulating this drug in an inert capsule. As it's distributed through the body, it doesn't cause any damage to the cells until somehow it is triggered. The body will flush the drug after a certain amount of time, but if the tumor can take this up preferentially, now I have a concentration of this poison encapsulated in an inert cover accumulated at the tumor. Now trigger it. Maybe that's ultrasound, maybe that's ultraviolet light, maybe that's X-rays, maybe it's some sort of other chemical reagent. By having this targeted drug delivery, now you can have very focused and localized effects, and this can prevent damage, collateral damage to the body. With drug therapies and pharmaceutical sciences, this is where we collaborate very closely with people, particularly at UNC Chapel Hill. Pharmacoengineering would be chemistry and some chemical engineering applied to the human body. All the way on the opposite of pharmacoengineering, from the squishy all the way to the electronic side, is medical microdevices. Medical instruments can span the gamut from externally mounted devices, such as external prostheses for the hand, all the way to internal devices like pacemakers that need to be able to generate electric charges to the heart. Biosensors are also important. If you have a glucose monitoring device, yes, it might be able to deliver insulin at some particular time, but it also needs to know when is that necessary, and that requires interfacing with the blood system. By having all of these devices, they have to be very small, which requires micro and nanofabrication techniques. They need to be able to pass small fluids to run assays on them. That requires a good knowledge of microfluidics to screen cells as well. So all of this stuff requires not only a good foundation in electrical engineering, but also how do these devices interact with the body? Do they cause immune responses? Can they adequately image the blood without causing clotting, for example? So these are major issues with microdevices. This is electrical engineering applied to the body. Finally, biosignals and imaging. Signals in imaging would include imaging techniques, as well as using those imaging techniques for diagnostics and treatments and targeted therapeutics. You can imagine any three letters, and I can give you an imaging technique that's based off of those. MRI, PET, CT, X-ray, ultrasound, XRD, XRF, XFs, all of these things have an application, and your job is to know when do I use them, what do they see, and can they be used for treatment as well. As far as X-rays, you're probably familiar with X-rays. If you've ever broken something, that X-ray can see the crack in a bone. But with proper focusing and coming from different angles, that X-ray can also cause cellular damage, which can be used to target, say, a tumor, for example. Ultrasound, basically you're just generating heat if you're not careful. But that heat might be bad. It might cause hyperthermia. Targeted at particularly bad parts of the body, that hyperthermia can kill off nasty cells. So what we do with this is a combination of physics as well as some electrical engineering, all applied towards the human body. These 5 areas are where our faculty members define themselves. Some, of course, will span multiple areas because biomedical engineering, like most sciences and engineering, is not discretized into bins. But what we would like you to do is to try to find out 1 or 2 of these that are of a particular interest. And that process starts from your first year. When admitted to the university, you are not in the biomedical engineering program. You start out as a generic student, and your goal is to take certain introductory science and math classes. we have a whole bunch of chem, physics, math, and bio classes that you'll take over your first couple years. After taking certain ones of these that I'll talk about in a second, you are eligible to apply to the biomedical engineering program. When applying, we follow the procedure defined by the College of Engineering at NC State, at both NC State, of course, and UNC Chapel Hill. We consider three things. The Engineering Success Score is a GPA calculated from Physics 1, Chem 1, Calc 1, and Calc 2. Also, we require a 300-word essay. I'll talk about that in a second. Lastly, we look at your cumulative GPA, though the main focus in our admissions process is on your Engineering Success Score and your essay. Generally speaking, students need a mix of A's and B's in their ESS to be a competitive applicant. This is not to say that students with B's and possibly a C are not eligible, though we have many students that apply. We can only take so many of those students. So please, keep your grades up, try to do your best in those classes, because it doesn't get any easier once you're a biomedical engineering student. If you have AP credit, the AP credit will count as well. You can look at the College of Engineering's website to see how a 5, a 4, or 3 in these classes translates into grades used in the ESS, though they do not factor into your cumulative GPA. The essay is 300 words, as mentioned, and what we would like to know is, given our limited resources, what will you do with our program? We can only accept 80 students, so what motivates you into BME? What things will you do in our program? What things might you do when you graduate from our program? A good essay can help a lower GPA still get into the program. So make it count, make it from the heart, and there is no perfect essay. We have things that we might like to see, but your goal is to tell us what will you do with our program and why should we accept you. We have students that have no doubt been influenced by other people to go into BME, and that's not the best motivation. We want to make sure that it's something that you would like to do and you know what to do with it. Of applicants, we accept 80 students per semester. The number of applicants total varies from year to year, but we always have more students applying than we have spaces. We take approximately 16 students in December, 60 students in May, 4 students in August. There is inevitably a small amount of attrition, so we will continue to fill spots in the program after the 3rd semester and even possibly into the 4th semester. But please try to be already affiliated by the end of the summer of your first year. Otherwise, you should strongly consider another major so that you stay on track to graduate in 4 years. If you want to apply multiple times, that is okay. Suppose you were eligible after your first semester, you applied and you were denied. If you would like to, you can contact the admissions committee and find out what you could do to improve your application, though generally that's something that you probably know, whether that's improving your grades or taking more STEM classes. Then you can reapply and reapply and reapply. There's no penalty for reapplication, though at some point you should consider that you may need to apply to another major. Once you're affiliated with BME, you'll be taking several engineering fundamental classes. You'll have a semester of design, and then a semester of each of these: materials, mechanics, electronics, and programming. This is in addition to some of the earlier science and math fundamentals that you'll still be taking. We are trying to make you proficient in all aspects of engineering, because when you graduate from our program, you will be an engineer. There are some other engineering programs, biomedical engineering programs, which may not emphasize all aspects of science and engineering. Ours does. You will be a strong engineer. Over the course of these classes, we hope you discover your interests. Do you like material science? Do you absolutely detest that Husseini fellow that's teaching you computer programming? Maybe you find that it's really materials that's always piqued your interest. That should instruct you in taking the next level of electives. In your junior year, you will take at least 3 gateway electives. Additionally, you'll take a semester of design and 2 semesters of human physiology so that you know every crevice and corner of the human body. With the gateway electives, these are to prepare you for the upper level electives that fall within our faculty's areas of research. This spans the gamut from biotransport to mechanics, all the way up to electronics. And the goal of this, again, is to prep you for these harder classes. So these are still fundamental engineering classes. In your senior year, you will take some upper level electives. But before you can pick from those, you should take a look at the list of electives that we have and figure out which are of interest. By specializing, now you can present yourself as one focused biomedical engineer rather than a master of none. The specialty electives we have, and this is a tentative list, are from those 5 areas. So pharmacoengineering, you might take classes in genetic engineering, targeted photomedicine, immunoengineering. You're interested in rehabilitation? Well, we have classes on orthopedic biomechanics, neurobasis of rehab engineering. If you like microdevices, we have fluidics classes, digital control systems, a lot of these electives. Now, in addition to taking electives within the biomedical engineering program, we have other electives, as you can see, in the physics departments and other engineering departments at NC State, in some of the biological and other applied physics, applied sciences of UNC. So we are trying to get you to have a lot of choices to best prepare you for how you want to focus in biomedical engineering. Those specialization electives all fall within one of these 5 bins. You will take 4 classes from no more than 2 of these areas. We still do want you to focus a little bit. In addition to those electives and 2 semesters of senior design, you are now a full, well-rounded biomedical engineer. It's time to go off into the world, graduate, cure all diseases, profit, kick back some money to this video talk that you heard that inspired you to go into BME, and my financial information is available on the website. If you are astute, you've also noticed that on this map I have F and S's in both Wolfpack Red and Carolina Blue. Since we can't offer every class every semester, we have some classes that are offered at NC State in the fall, some in the spring, and if it's offered in the fall on one campus, it's offered in the spring at the other campus. So you'll see that in the biotransport on the left of the gateway electives, transport is offered fall at NC State and spring at UNC. So this is one of the benefits of our program. The fact that it's a joint program means that we can offer multiple classes off semesters, so that if you'd like to study abroad, if you have a medical emergency, or need to take a semester of leave, you won't fall behind and can still graduate on time. In addition to the multiple classes, there are additional benefits of being a member of the joint program. First, when you are accepted into biomedical engineering at one campus, you are registered and given full student status at the other school. Now you carry 2 IDs. You are a student and can do anything on the other campus that a student that applied and was accepted there can do. So you have 2 student statuses. You can now take classes at either school. The reason we have these 3 locations, NC State, UNC, and Research Triangle Park, is to give you the full life cycle of a product. Develop it, make it, prototype it in the engineering school at NC State. Do some preliminary animal model testing at the vet school. Bring it to UNC, to the medical school, the dental school. Do some human testing. And now, once you've got a device that's got some evidence that it's working, go to the Research Triangle Park and mingle with people with lots of money looking to invest it in new technology and get those business and investors interested. This is the whole life cycle of a product. Outside of classes and working with these different areas, as a student of both campuses, you can do anything you want. Rec facilities, libraries, IT service. You can have email problems and get email spam and weather alerts from 2 campuses instead of just 1. We can help you get parking. You can take advantage of entrepreneurship and internship opportunities that are specific to each school. NC State has a big engineering school. You may want to go to the career fairs over there and use their engineering career placement resources. UNC has a big medical school and pre-med program. You might want to go over there and get some feedback on your med school application. Student organizations. You know, you're an NC State person, but you really still deep down inside bleed Carolina Blue. Now you can go join the Tar Heels clubs. If you're a UNC person and you bleed red like a normal person, you can go be with the Wolves or whatever they call themselves. You get meal plans. We're working on housing. We've had students that have lived at the other campus for a whole semester. Your diploma will have 2 seals with 2 very important people signing it. Yes, you can get student tickets at sports games, but that could always be abused. The moment that somebody important at one school sees on ESPN that there is a bunch of Wolfpack fans sitting in the student section of a UNC game wearing red shirts with biomedical engineering on it, that's when that privilege goes away. So please be cautious about it, but yeah, you can get student tickets at any place. Importantly, you never have to go to the other school. There are only opportunities. You can complete your major without ever setting foot at the other school. But things like senior level electives, those upper level specialization electives can only be offered at one school once a year, so there may be reason to go back and forth. We have a shuttle that runs every other hour from each campus to help with the transportation process. Again, no requirements, only opportunities. After graduation, our students go a variety of places. About half of them go into industry, with companies ranging from pharmaceutical companies to working with governmental organizations, consultancies, medical record device companies. So if you want, you can go into large companies, small companies, start your own company even. That's part of our design process, is to prepare you to come up with your own devices and bring those to market. About 20% of our students go into pre-health programs, or health programs, including med school, prosthetics and orthotics schools, dental, vet schools, etc. Our major covers nearly all of the pre-med requirements. You should always check with pre-health advising to verify that you're on track, because each med school has their own requirements. But generally, you'll have to take 3 additional classes. Our program covers all of the things from physiology to the first semester of organic chemistry to the math and physics that you need. About 20% of our students go into graduate school. That can be industry to get higher status jobs or more managerial positions, or you can go into academia and be like me and never leave college. Finally, about 10% of our students go into other things, whether that's the military, the Peace Corps, change majors completely, social media influencer, or maybe take a leave of absence and do something else. Our students find, more than 90% of our students find jobs within 6 months. So we have a very good success rate with our graduates. Lastly, our program is a tight-knit group of people. We take 80 students at NC State, 80 students at UNC per class, and everybody seems to know each other. We try to mingle with people during design sessions so that teams from both schools can meet each other and see each other's presentations. In the bottom left, we work hard. Those are some of my biomechanics students. If you look at the window, it's pitch black outside, probably because it's 3 a.m. But look, they're smiling and laughing. They must love it. On the right, you see our graduation picture. It would be unfair to have everybody go to a UNC or NC State, so we make it equally difficult for everybody by having our graduation at neutral grounds. And in this case, this was at the Carolina Theater in Durham. Everybody wears their own gown, but we have a joint department ceremony. Everybody gets a diploma with 2 signatures. We try to mix them up together, but let's be honest, people still tend to clump up a little bit with their buddies from their own school. Red and blue, I don't know if they necessarily match, but we do our best to keep it as a close-knit group of people. In conclusion, we have a joint program that has some unique opportunities that no other school has in the country. If you still have questions, feel free to contact me at the email listed, Rocky Rothrock, who is our UNC Student Services Specialist, and Leslie Hubbard, who is our NC State Student Services Specialist. All of us are happy to help you and answer any other questions that you may have. We look forward to seeing your applications soon, and best of luck in the engineering program.